this video, we are going to explore what is meant by isotropic antenna, omnidirectional antennas, and directional antennas. An isotropic antenna is a theoretical antenna that radiates equally in all directions. If you see the radiation pattern, you can see it's like a sphere. So you can see that it is radiating equally in every horizontal and vertical direction. So if you consider this antenna, it has a gain of 1, that is 0 dB in all the directions. So this type of isotropic antenna does not exist. This is just an hypothetical concept. We usually use this isotropic antenna as a reference antenna to evaluate other antennas. You know that we are considering the gain of the antenna like dBi. This means that we are measuring the gain of the antenna with respect to an isotropic antenna. So this isotropic antenna is just a hypothetical concept. In case of an omnidirectional antenna, they radiate equally in all the horizontal directions, but not in vertical direction. So if you consider the radiation pattern, it will look like a donut shape. So it has the radiation equal in horizontal direction, no radiations in vertical directions. If you compare the isotropic and omnidirectional antenna, we can see that the radiation in the vertical direction is directed to the horizontal direction in case of omnidirectional antenna. So the gain of the omnidirectional antenna is more than isotropic antenna. It will be around 2 to 9 dB. As it has a horizontal coverage, it is mainly used for wide area coverage applications like base stations and Wi-Fi routers. And we can see that as it is covering entirely in all the horizontal direction, it is very easy to install. We don't have to specify like whether this tilt will cause any issues or something like that. So it is very easy to install these type of antennas. And as the radiation is equal in every direction, it is also prone to interference from other directions. These are some of the omnidirectional antenna examples, and in common they have different applications like public Wi-Fi hotspots, cellular base stations, broadcast radio, security, CCTV, vehicular antennas. Where we need these horizontal coverage, we can use omnidirectional antennas. In case of a directional antenna, it concentrates most of the energy in a particular direction. You can see that most of the energy is concentrated in this lobe. So when we use directional antennas, we can have more coverage and gain from this lobe. So it is mainly used for long distance communication. As we know that the gain is concentrated only in a particular lobe, if we want to install the directional antennas, we have to be careful about the installation. The installation has to be more precise, otherwise it will cause the tilting on these antenna lobes, and it will cause the reduction in the range of coverage. So when you compare the directional and omnidirectional antennas, these directional antennas can provide more gain than the omnidirectional antennas, as it is mainly concentrating all its radiation intensity on a particular lobe. These are some of the example of directional antennas like parabolic reflectors, Yagi antennas, and the patch antennas. They have different applications like radar systems, satellite communication, point-to-point communication, wireless bridges, military and remote sensing applications where we require the radiation intensity to be concentrated in a particular direction. I included this picture just to show what is the difference between omnidirectional and directional antennas. Here you see that if it is an omnidirectional antennas, it can provide wide coverage in any direction. So this can accept the signal from whichever base station is near to that. But in the case of a directional antennas, only this lobe has the maximum power to accept the signal from any base station, so it won't be able to accept the signal from other base stations. So these type of antennas are mainly used for point to point communication, and this is for the wide coverage communications. I hope you get some idea about what is meant by isotropic, omnidirectional and directional antennas. Thank you. Kindly support and subscribe.